Section 3.5. 3.5 is a section that I really like. And it's going to feel a little bit like what we did with Venn diagrams. Slightly different application, but they look similar, okay? They're not going to have numbers in them and things like that. It's going to be contextual information, like the things we've been working with our arguments. But these kind of diagrams are not Venn diagrams, okay? They're actually called Euler diagrams. So this word right here is not, get me the right color here. It's not Euler. This is Euler, okay? So, yeah, so that's how you pronounce that, Euler. Can everybody say Euler? Euler. Yeah, that's Euler. So these are Euler diagrams. It's a mathematician's name, so, you know, phonetics don't always work, right? Your name doesn't work. My last name, my maiden last name, just for funsies, I'm going to write it for you and let you try to pronounce it. What do you think? It's really close. Nope. It is Schirn.
I knew it! Oh my God!
Did you really? Yep, it is Schirn.
Wow.
So it's German, and so that SCH blends for the SH sound. And then I had a piano teacher once who said that she remembered how to spell it because it's just like Old MacDonald. E-I-E-R-N. There you go. So, yeah. So names are kind of weird sometimes. They don't follow all the phonetics. In fact, a lot of words in English don't follow phonetics either. And Euler is another one. I mean, it's not an English name, so it kind of makes sense that it wouldn't necessarily follow some of our conventions in English. So we're going to be taking a look at arguments, like I mentioned. And these are going to be either valid or invalid arguments that we're going to make decisions about based on Euler diagrams. So a valid argument is a statement, or a statement is valid when all the premises are true, it forces the conclusion to be true. If all the premises, the parts of the if parts are true, then the then parts are forced to be true. Invalid is simply the opposite of that. It's not valid. We also use the word fallacy for something that's an invalid statement. So those are two synonymous words. And then, as mentioned, Euler diagrams are a lot like Venn diagrams. So the different types of diagrams that can show up for Euler diagrams look like the following. You can either have circles that are embedded inside each other. I'm going to draw two circles for each of these. You can have circles that overlap. So that kind of looks like, the first one kind of looks like our subset notation. The second one looks like most of the Venn diagrams that we drew. Or you could have two circles that are completely disjoint. I'm going to make that disjoint. Give me a sec. There we go. Now they're not touching. Okay. So these are our three different options for how Euler diagrams may present themselves. And they each follow a different convention of language. So I'm going to give you an example for each one of them and show you how they fit together. So the first example is a phrase or a sentence that's going to say, all dogs go to heaven. So the circle inside is the circle that represents the all dogs. And the circle that surrounds it is the representative circle for things that go to heaven. So if it's a dog, okay, so I have a dog, Molly. Molly would be inside of the circle that's like the dog circle, which means she's inside the bigger circle that things that go to heaven. Therefore, Molly would go to heaven according to this statement and this argument. Okay, does that make sense? So this is the picture, and you have this picture anytime you see that word all. So the key word right here that's forcing this to happen is that word all, the embedded circles. Okay, the second one, we'll do an example. And we're going to do some people are mothers. And the key word here, kind of like the word all, is the word some. Okay, so all is those universal quantifiers we talked about. Some is the existential quantifier. So these are the two different categories so far. Some people go to heaven, some people are mothers. So this category on the left would be, oops, I didn't mean to write the word some. Erase that if you did too. It's people. Okay, these are all the people. And on this side is mothers. Now, the people category and the mothers category are overlapping, right? I'm in the overlap because I'm a people and I'm a mother. But there are some people, many of you, in fact, probably most of you are not mothers. You're in the people category, but you're not in the mothers category, which would put you kind of in this outer region right here, right? But there's also this category that's mothers that's not people. So what would that be? Dogs and cats and things that have animals, right? They give birth, right? They're mothers as well. So they'd be in this outer part. So yes, they overlap. There's things in the overlap, but there's also things in each of the pieces on the outside. Okay, so this phrase right here would be the phrase some, and you're going to get these overlapping circles. So any idea what this last one might have phrasing for?
No.
It is. It's no. Very good. So we're going to do no hamsters live at my house. Now, one category would be hamsters. And the other category would be things that live at my house. Okay, so things that live at my house, that would include the dog I mentioned, Molly. We have 2 cats. That's Olive and Penny. And right now it includes a fish. My daughter got a fish at VBS this summer, and it is still alive, which is pretty impressive. It's a betta fish. They're easy to kill, actually, too. And it's still alive, and its name is Mr. Bubblebutt. Yeah, that's Jules' fish, and she doesn't remember to feed it, which is also a very remarkable statement since it's still alive, and it doesn't get fed very often. So, all right, so these categories are completely separate, right? Hamsters are somewhere, but they are not in my house to the best of my knowledge, though a child has asked for one. The answer is no. Okay, so what we're going to be doing is we're going to be taking statements, and we're going to be creating these kinds of circles. Some are going to be embedded circles, some are going to be overlapping circles, and some are going to be separated circles, okay? And then we're going to decide if the argument is valid. So in a very real sense, what you have is you have 2 statements, right? Each of these are a premise. So this is premise number 1, this is premise number 2. Both of those things are assumed to be true, right? Over here where it talks about valid and invalid. If the premises are true, the first 2 statements are true, the question is, does it force the conclusion to be true? And this is the conclusion, okay? So these are premise. I need to change colors because this is not a good color. Let me show you with the yellow. And this is our conclusion. Okay, we want to see if the first 2 statements being true force the last one to be true. And these diagrams can help us to identify that kind of a statement. Now, the reality is that inside of my math lab, sometimes they're going to give you a question like this, and they're going to say, which Euler diagram fits the category, right? They're not asking you if it's valid or invalid. Or they might ask you to decide if it's valid or invalid, but they don't actually ask you to create the Euler diagram at all. So in theory, you could probably just a 50-50 shot and you might be right. I mean, like, right? But then again, if you're wrong and it's homework, then it just bumps you out and you get a different question completely and you got to start over from scratch. If it's a quiz, you just missed the entire question because you didn't do just a little bit of work on the front end to make sure, okay? So we're going to do the work to make sure that we have the ideas here. All right, so this first statement here says, all politicians lie, cheat, and steal. Okay, so what kind of circles is that telling us to create?
Circle within a circle.
Circle within a circle. So we've got a circle inside of a circle. So we're doing one statement at a time, and we need to label them, otherwise we're not going to be able to identify the pieces later. So what is the inside circle going to be? It is. Good. So this is politicians. What's the outside circle going to be? Yeah, and just to make it a little bit more defined, I'm going to say people, or you could say those. I'm going to say people who lie, cheat, steal. Okay, now the argument is not asking you to decide, is this true or is it false? That's not the point, okay? This is the statement, and we're assuming the statement to be true, and we're going to keep going. Okay, this is the structure of the statement we were given. Everybody good with that? Okay, the next statement said, that man lies, cheats, and steals. Now, we haven't talked about how this works yet, but the way that this works is we have a single person now, okay? There's one person. You can even give him a name if it helps you, Jack. Okay, it said man, so we'll go with Jack. Okay, we don't have a Jack either in this class, so that's probably good. We're not to identify Jack that way. Okay, Jack, it says Jack lies, cheats, and steals, or that man lies, cheats, and steals. Well, the question is, where could that man go in this diagram and it fit within the constructs we've already got? Well, that man, I'm going to call him X. So this is our that man, or you can call him Jack. If he lies, cheats, and steals, he could go right here, correct? That's the lies, cheats, and steal category. Where else could he go? He could go in the very center, right? Either location would be appropriate to put him inside of the outer circle that says lies, cheats, and steals. Now, looking at the locations where we just put the X, can you guarantee, based on this diagram, that that man, Jack, is a politician? No. So this would be an invalid argument. Now, suppose for a moment, instead of it being structured this way, that second statement did not say that man lies, cheats, and steals. It said that man is a politician, right? And the conclusion is that man lies, cheats, and steals. That changes things, doesn't it? Okay, so the order in which this is given really matters. We got to make sure that we create the diagram with the first two pieces, and then we examine in the validity based on the last piece. Sound good? Let's try another one. All right, some nurses wear blue uniforms. So we're going to start with that piece. What kind of circles does it tell me to create? Overlapping, good. Okay, what are my overlapping circles going to be labeled? Nurses and people who wear blue uniforms. You can feel free to abbreviate it to the fact that you can identify what you're talking about. I'll be a little bit more descriptive in mine. Okay, does that make sense? So nurses and blue uniforms overlap. So you've probably seen some nurses that wear blue uniforms before. You've probably seen other professions of people who don't. So what are some professions of people who wear blue uniforms? They're not nurses. Dentist, okay. Veterinarians. Actually, branches of our armed forces do too. Marines, those are blue, right? Yeah, the Marines wear blue uniforms. How about police officers? A lot of times police officers will. Mechanics. I mean, so there's lots of things, right? So these are overlapping circles. They don't include one inside of the other. And the statement also says that, right? It says some nurses wear blue uniforms. Now it says D. Boyle is a nurse. So the second statement is often, not always, but often the place where we are identifying a single person or a single category of people, a smaller category. So our X is D. Boyle. Okay, so where can I put the X's or X? Okay, it can be in your nurses category. It could be in the center because that's part of the nursing category, right? Okay, so those are the locations for D. Boyle. Based on that, do you know if the last statement is forced to be true? No, it's not, right? D. Boyle could be in the outer part where she's a nurse that gets to wear, something different than blue. Or maybe she's in the category in the middle, and she does, but we don't know for sure, which makes this another invalid argument. Okay, ready for another one? All right. All disc jockeys play music. How am I going to draw my circles? One inside of the other. Good. All right. What's going to go in the inside circle?
Disc jockeys.
Disc jockeys. And I'm going to abbreviate. These are DJs. What's the outside circle? People who play music. How many of you play music? I do occasionally. My son plays music. My son just got a car last week. It's very exciting. So exciting that he had to clean the car almost immediately and vacuum it out, playing music with the gas running the whole time.
Oh.
Yep, totally happened. But he played music, so he's in this outer category. Tell you what, he's not a disc jockey. Okay, so here's our first category setup, right? Now we've got Flash Phelps. So our X is Flash Phelps. It says Flash Phelps is a disc jockey. Okay, so where can I put the X? In the middle. Can I put it anywhere else?
Yeah.
I can't. Why can't I put it anywhere else? Like, why can't I put it here?
Oh, because he is a disc.
Because it really says he's a disc jockey, so he has to be in the circle for disc jockeys. If I put him out here, where I just tried to put him, right? Whoops. He wouldn't be a disc jockey, right? This is my son out here. It's what many of you probably are out here too, right? You're in this outer circle. You're not a disc jockey. I can't put Flash here because it says he's a disc jockey. So Flash goes right there. All right, so this is the setup. Everything before that, therefore line, okay? Is the conclusion forced to be true? Does Flash Felt play music? Yes, he does, because he's in the bigger category of people who play music. So this is our first one that is valid. This is a valid argument. I like Euler diagrams because I really think visually. This, to me, just sort of, I don't know, it hits home because I can see the picture of what's happening. All right, another one. No dogs or cats. Okay? How am I going to draw my circles? Separate circles. And I do hope that we can agree that these are separate categories. Although, even if you don't agree, that's what the statement says, so we're going to draw it that way, okay? All right, so we got dogs on the left. We've got cats on the right, or vice versa, if you prefer. All right, no dogs or cats. So disjointed circles, disconnected circles, non-overlapping circles because of the word no. And then it says Deke is a cat. So X is Deke. Deke was our first cat, actually. We don't have Deke anymore. He'd be like, I don't know, 26 or something. That'd be very old for a cat.
Why'd you name him Deke?
I don't know why we named him Deke. I'm not really sure. But he was our very first animal that we ever got, Deke. Okay, so where can I put the X? Cat circle. Can it go anywhere else? No. Okay, so the conclusion. Deke is not a dog. Valid. Yes, it's both true and valid. The argument is valid. Okay, so there's going to be some that you're going to do that are going to be set up like this. I wanted to give you a smattering of things, both that were valid and that were invalid, that included all the different kinds of argument styles and the pictures and so forth. But some of them are also going to be given to you where they've created the picture. And you're going backwards. You're creating the valid argument, right? So just like with the previous ones, we're going to start with the circle structure. Is it all, some, or none, right? That's where we're going to start. So the circle structure, which circle kind do we have? All. And what will our statement say? All what? Fantastic. We start with this inside circle and we work out. So all cat lovers are pet lovers. Again, you may disagree with the statement. It really doesn't matter. That's the structure set. That's what we're working for, right? Okay. The next thing we're going to do is we're going to talk about the X in the picture, right? That X on the side over here says that it represents Jessica Long. So what is a statement that you could make about the X? Yes. Jessica Long is a cat lover. So what is a valid conclusion based on this structure? Right. Jessica Long is a pet lover. Okay, what do you think?
Okay, I'm with you.
Okay, so far.
I'm
Okay.
never with you, but I'm with you.
All right, our next one is a little more complicated. There's not a lot of them like them, but I think I've got a couple of them in there. What do you think might make this more complicated just looking at it from just a broad picture? There's three prompts. We see the word some, and we see the word all. And we don't have a specific person mentioned, right? It doesn't say Flash Phelps. It doesn't say that man, and it doesn't say Jessica Long or Deke, right? There's not a very specific piece mentioned. All right, so as we're looking at this, we're still working the same way we did before. Take it one piece at a time and build the diagram. So the first piece says All people who drive contribute to air pollution. Okay, I'm going to be flipping back and forth between pages because I don't have enough space on this one. So what will that part of this diagram look like? Circle inside a circle. Whoops, let me get my circle tool. Okay, what's going to go on the inside? People who drive. And I'm just going to write drivers, right? People who drive, drivers. What's going to go on the outside? Yeah, contribute to air pollution. All right, so presumably it's not just the drivers who are contributing to air pollution. There's other things too that would be in this outer category. So that's why they're sort of setting it up that way. All right, the next statement says, all people who contribute to air pollution make life a little worse. Now, pause for a minute. You don't have to agree or disagree with these statements, right? That's not the point. The point is to create the diagram. What would a diagram look like if we just looked at that middle statement? All people who contribute to air pollution make life a little worse. A circle and a circle, okay? So the inside circle would be what? People who contribute to air pollution, right? So if I were drawing just line 2, it would look like, do it again, it would look like this. And the inside circle would be the air pollution, and the outside circle would be the people who make life worse, right? Okay, but this air pollution circle right here is already in my diagram, isn't it? It's just the circle that's already on the outside. So what do you suppose we would have to do next? You bet. Make another bigger circle. Those are some pretty good concentric circles right there. Okay, so we have drivers. We have people who contribute to air pollution. What's this outer category? People who make life a little worse. Okay? Or you could even be more general if you want to and say things that make life a little worse. It doesn't really matter. Okay, so we've got drivers, air pollution, making life worse. This is the category setup. Okay, so that's our first two descriptive statements. Our next one says, some people who live in a suburb make life a little worse. Now, I recognize that this says some, and we've talked about overlapping circles for some, and you can do that on this. It's okay. But it really isn't necessary to continue that sort of an idea. It easily could have just said, Jack, who lives in a suburb, makes life a little worse. Identify it just like a single person, just like it's a small category. So while it is okay if you want to do it with those, I think it makes the diagram a little bit more confusing. So I'm actually going to use X to represent these some, actually, yeah, I'll write it. Some in the suburbs. I think that's how it describes it, right? Some in the suburbs. Some people who live in the suburbs. So it says some people who live in the suburbs make life a little worse. So where can I draw my X? People who make life a little worse. Can I put my X anywhere else? Are you sure? What if the X were in here? Do those people make life a little worse? Like if it weren't here and it were there, would those people make life a little worse? Yeah. What if it were over here? Do those people make life a little worse? Yeah. So they could actually be in any one of those three circles and still fit that last criteria. Because every piece of that diagram is inside the big circle makes life a little worse. Make sense? But we don't know where they are. They could be in all those places. They could be in one or two of those places. They could be in one single one of those places. Any of those are possibilities. All right, what's our last statement? It says, this is our, do we know for sure that this worked? Do we know for sure that some people who live in a suburb drive? Based on this diagram.
Yes.
Do we? Well, there's an X in that spot. Does there have to be an X in that spot, though? No, it could be. So these X locations right here are possible places. And in fact, that's how we did it on the other ones as well. These are possible locations. Come on. For X. So let me step back to the ones we did before so that you can see that's really not any different than we did it before. It just wasn't as confusing of a picture. So over here, the X was definitely in the category in the middle. There was only one of them there. Over here, the X was definitely in the cat's category. Over here, the X was definitely in the DJ's category. But on this picture, we had X in two places. Now, D. Boyle is definitely not in those two places. She is a single person. She cannot be in both of those places, but we don't know which one she's in based on that diagram, right? That's just like our some people. We don't know where our some people are. Maybe they're in all three places because they're more than one people probably, right? Whereas D. Boyle's one person. But these are just possible locations for where D. Boyle could be. Here, these are possible locations for Jack, right? We don't know where Jack is. He's actually just one person, so he's not in both places, but we don't know which one he's in. There are possible locations. So the same thing is actually true here too. These are possible locations for X. So since they're possible locations for X, it's also possible that X is not in all three of them, but it's only in one of them, and they might not be in the drive category, right? Yeah, so this is an invalid argument. Okay, that's it in 3.5.